Okay, we're going to do a quick tutorial here on how to solve quadratics using square roots. We're going to work on 4 different problems. They're going to get increasingly more difficult as we go on, but it should cover basically everything you need to know about solving quadratics using radicals. So we're going to have x squared equals 121 is going to be our first one. We're going to solve, technically the directions are solve, and so our goal is to figure out what x is. A lot of you right now think you know what the right answer is, and I'd say about 25% of you probably know correctly the answer. A lot of you are thinking that it's 11. It's not 11, it's plus or minus 11. The reason it's plus or minus 11 is because, remember, we're trying to figure out what is x allowed to be so that when I square it, I get 121. Well, positive 11 squared is 121. We know that. But negative 11, when you square that, when you take negative 11 times negative 11, you also get positive 121. So technically, to show the work in between here, we are square rooting both sides of the equation. That's what we're doing to undo the square. When you square root, this is a good thing to write down. When you square root, there will be a plus or minus sign. Okay? It always goes on the side that had the number to begin with, not the variable. But that's true. When you square root, there will be a plus or minus sign every time. Now, that doesn't mean your final answer is a plus or minus. It means that there will be a plus or minus involved in the process from that point on. So the next problem we're going to do to start getting a little bit of practice here is 3x squared minus 8 equals 19. Now, because while this is quadratic and typically we try to get everything equal to 0, what we also notice is that there's not a linear term. There's no something x. It's 3x squared and then numbers. Since that's the case, it's actually very beneficial for us to try and solve using the square root method, kind of like we did for letter A. So the first thing we're going to do is we're going to add 8 to both sides and get 27. And then when I divide by 3, I get 9. And then when I square root both sides, I use a plus or minus, and I get plus or minus 3. Again, that's our final answer, just like this one was. I just forgot to circle it. Okay, so we're going to move on towards complexity here. So letter C. Letter C is going to be 2 times the quantity x plus 3 squared minus 8 equals 42. What I'm going to recognize here is that this is a perfect square. It's something squared. And the rest of what I have is numbers. If that's the case, then it's actually really beneficial for me to try and isolate the squared stuff. That's a technical math term, squared stuff. Yeah, so what we're going to do is we're going to get this isolated by doing the same steps we would do if it was just 2x minus 8 equals 42. Same steps. We're going to add 8, which gives us 50 on the right-hand side. And then we're going to divide by 2. Okay, and now we have something a little bit nicer looking. Now what's really nice about this is that I have a mystery amount squared equals a number. I can square root this just like I did when it was regular x squared without the plus 3 in there. Square root both sides. So that's going to give me x plus 3 is plus or minus 5. Remember, plus or minus every time there's a square root. From that point on, I actually have two different equations. I have x plus 3 equals 5 and x plus 3 equals negative 5. Now some of you are going to look at this and go, wait, Mr. Wilkins, can't we just subtract 3 and make it plus or minus 2? And to that I say no, you can't. Sorry. Let's find out why. On this one, I subtract 3, I get 2, as expected. On this one, I subtract 3, and negative 5 minus 3 is, well, wait a minute. That's negative 8. Yeah, that's going to happen. You have to be prepared for it. Just because you have a plus or minus somewhere in your problem doesn't mean that the final answer is a plus or minus. We actually do kind of have a plus or minus. We have a positive 2 and a negative 8, but they are different numbers. Let's go to letter D. This is the last one we're doing. So we're going to do 2 times the quantity x squared minus 4 equals 1, what is it? 156. There we go. So let's see, what should we do first? Well, we have a couple options here. We could distribute the 2, and that would be okay, but we could actually get rid of the 2, and that would be more beneficial. I'm going to take a look here. If I divide both sides by 2, then the x squared minus 4 is left, and this becomes 78. And then I add 4, and this becomes 82, and then I square root both sides. Okay, x equals plus or minus. Now 82 is not a perfect square, so I'm going to do a quick side work here. That's 2 times 41. 41 doesn't break down, that's a prime number. Okay, I don't have any pairs of factors, so okay, yeah, I can use the square root of 82 as my answer in that case. We don't need to get decimal answers here. I prefer exact solutions, which is radicals. If I ask for answers rounded to the nearest hundredth, then you would do that. Now let me go back to a common question, and this is back to letter C. I'm going to rewrite it here. 2 times x plus 3 squared minus 8 equals 42. Now there's a whole bunch of you that would have wanted to square the x plus 3. Now there's actually, I'm going to divide this out so we remember this. There's actually no problem with squaring the x plus 3. The problem is that a lot of you will do that incorrectly. When you square x plus 3, you're taking x plus 3 times itself. You're not squaring the x and squaring the 3, and so that's where the issues happen. I could actually square that, and I'm going to get x squared plus 6x plus 9 minus 8 equals 42. And then let's see here, I'm going to have to distribute the 2 because now I have a linear term. So now I can't do the square root thing anymore. I've gotten that. So now I could distribute the 2 and get 2x squared plus 12x plus 18 minus 8 equals 42. And that'll give me 2x squared plus 12x plus 10 equals 42. See, now I'm in the position where I need to solve either using the quadratic formula or by factoring, which means I need to move the 42. So now I have 2x squared plus 12x minus 32 equals 0. And then I need to pull out a common factor, or I could go straight to the quadratic formula from here. But have something like this equals 0. Okay, things that multiply to make 16, negative 16, and add to make a positive 6. Let me make sure I did this correctly. I feel like I'm missing something here. Let's see. That was 18, that was 8, that's 10. I subtracted 42, that should be negative 32. I divided a 2 out of each of those. Okay, so let's see. Did I do something incorrectly earlier? No, we're good. Okay, just double checking. So I have this 2, and then this actually becomes an x minus 2 and an x plus 8 equals 0. And so then x equals 2 or x equals negative 8 based on your solving by factoring that you've learned about. Same answers, different process. Now the issue, I don't know if you can see it here, but that's a whole lot more work than this. Now it looks like it took up the same amount of space. It did, but you'll notice I only had 5 lines here, really. This one had more like 8 lines. So that would be the part that takes a little bit longer. Is this one wrong? No. Is this one the only right way to do it? No. You can do it either way. I'm just showing you that if you were to square the x plus 3, you do have to remember that it's x plus 3 quantity squared. Now, I will say, if we got to this point right here, and we had to do the quadratic formula from there, that's going to be another at least 5 steps. So that's where it starts to really add up in how many steps you have to do. And that's why it's nice to recognize that this one, we can use a square root because there's a something squared and the rest of the stuff is numbers. That's kind of the nice part. So there's your quick tutorial on solving using the square root.